Hello, and thank you for tuning into this webinar. I'm Bart de Klerk, a member of the Department of Mathematics at RMA. I'm excited to share with you today how techniques from mathematics and AI can contribute to social media intelligence. In fact, our department is actively involved in a research project focused on this very topic. This project aims to develop a comprehensive toolbox that helps analysts to effectively perform social media intelligence work. Today, we'll begin by establishing the context and ensuring that you have all the necessary background information. This will help you understand the importance and relevance of social media intelligence in today's landscape. Moving forward, we'll delve into some key challenges associated with data in the realm of social media intelligence, and once we've understood those, we'll explore various mathematical and artificial intelligence techniques that can be used for social media intelligence. Towards the end, I'll summarize the key points, provide some takeaways from the discussion. And finally, I intend to leave ample room for questions and answers. Open source intelligence, or OSINT, is a method of gathering information through publicly available sources. This information is then processed and analyzed to produce actionable intelligence products. The sources can be very diverse, ranging from commercial satellite images, newspapers, official reports, and various forms of internet data, including websites and social media platforms. A recent and powerful example of OSINT in action is its use in an ongoing conflict between Russia and Ukraine. The Ukrainian military has leveraged OSINT to track Russian military movements, plans, and operations. For instance, unencrypted radio communications have allowed Ukrainians to eavesdrop on Russian conversations. Cell phone connections have facilitated precision strikes on Russian troop concentrations, and social media posts have offered insights into where and how the Russian military is operating. And this brings us to the main topic of our webinar: social media intelligence. This is a subdomain of OSINT that specifically focuses on the collection and the analysis of social media data. As we've seen in the Russia-Ukraine example, it can play a crucial role in understanding and responding to complex situations. To understand the importance of social media intelligence, let's look at some recent examples where social media played a significant role. The 2016 and 2020 US elections, the Jurgen Konings case in Belgium, and very recently the Israel-Hamas conflicts all saw social media being used as a platform for manipulation and misinformation spreading. Other operations on social media can be less overt and can just try to subtly attempt to control the information environment, and so leading to development of cognitive bias that may distort our perception of reality. But essentially, what is SOCMINT? At its core, SOCMINT refers to the techniques and the tools that are used for the collection and the analysis of information originating from social media platforms. Implementing SOCMINT requires a broad range of tools and techniques. These include methods to gather data from different platforms, analyze conversations, including multimedia content, detect signals of interest, and provide a timely and appropriate response to new trends and evolutions. This webinar will primarily focus on situations where there is a substantial amount of data, making the analysis by a human analyst either very costly or simply impossible. However, it is important to note that some of these techniques can still be beneficial even when the amount of data is limited, as they can assist analysts in their work. Let's start with the data. The first challenge in SOCMINT is gaining access to the necessary data. To analyze at scale, you need substantial amounts of data, which can be obtained either directly from the social media platforms, through third-party data brokers, or by other means. However, it is still important to be aware of any legal limitations or restrictions that may apply. Once you have the data, you need to store it in a way that allows for easy access and control. Ideally, you'd want to retain access to the stored data indefinitely, which can require significant storage capacities and effective data management strategies. In most cases, you also want to gather information from more than one platform. So this means you need a data model that can accommodate data from multiple sources and allow for an integrated analysis within the same workflow. This is a complex task, given that different data structures and formats are used by different platforms. And as we all know, the content shared on social media is increasingly multimodal, encompassing not only text, but also images, audio, and video. As an analyst, you need the ability to process and analyze all these types of data in a way that fits your workflow. This requires sophisticated tools and techniques that can handle the complexity of multimodal data. Now, let's have a look at some of the techniques that can be used. Today, we'll dive into three different techniques that can be helpful in the field of SOCMINT. First of all, computer vision, then natural language processing, and finally network science. Interestingly, we'll be exploring these techniques in reverse chronological order, and the reason for this will become clear as we progress. It is important to note that these three techniques do not encompass the entire range of tools that can be used in a SOCMINT context. However, they do represent a subset where having a mathematical or an engineering background can be particularly beneficial. First of all, let's look at computer vision. Over the past decades, computer vision has made significant progress. We have multimodal language models like GPT-4 Vision, Cosmos 2, and Lava that can not only describe images that are fed in a system, but they can also answer questions and reason about those images. This advancement has opened up new possibilities for image analysis and interpretation. We also have segmentation methods, such as Meta's SAM, that have improved dramatically. These methods can accurately segment images and use the results for downstream tasks. This allowed for a more detailed and nuanced analysis of visual data. And finally, we have high-quality object detection methods that have become more adaptable and that can be fine-tuned for specific operational needs. For instance, you could fine-tune one of those for semi-automated recognition of equipment in photos or videos. This capability enhances precision and efficiency of image-based analysis in SOCMINT. Up next is natural language processing. Just like computer vision, natural language processing has seen a significant capability increase in recent years. We have models such as Whisper or Seamless M4T from Microsoft that are capable to transcribe and simultaneously translate text or audio across multiple languages, greatly enhancing our capability to understand and analyze things in a multilingual context. We also saw the development of multilingual embeddings, which are basically numerical representations of texts or words. And this allows us to detect similarities between content across multiple languages. And this again is a powerful tool for cross-linguistic analysis. You all know ChatGPT by now. The rise and availability of these large language models have also made it possible for us to interact with and query our data in natural language. This can make data analysis more intuitive and accessible even for those without a very developed technical background. And given the large amount of data that is typically involved in social media intelligence, large language models can also be used to generate summaries or profiles based on content that users share in a specific context. This can help an analyst to distill key insights from large amounts of data, making the entire analysis process more efficient and more manageable. The third field is network science. Network science is a well-established field that has been around for several decades. It focuses on the study of complex systems represented as networks, where we have nodes that represent entities and edges that represent relationships or connections between those entities. The most direct application of network science in SOCMINT is social network analysis. In social network analysis, nodes typically represent users and edges represent relationships between those users. Relationships can be being friends on a social network, sharing a specific post, and just social network analysis in itself can already provide us with a wealth of insights into the social dynamics and their interactions between users on platforms. However, we can go beyond simple social network analysis. We could consider different types of networks, such as multi-layer networks, where each layer can correspond to a different social network. We can also be creative with the definition of nodes and edges. Nodes could represent users, but also websites, videos, and other things. And the connections could be based not just on direct interaction, but also on content similarity, user activity patterns, and other options. And next to all of those things, we also have the opportunity to apply both supervised and non-supervised machine learning methods on network data. This can further enhance our capability to detect patterns, make predictions, and gain insights from complex social media data. Now let us consider a hypothetical scenario where we have a social media account that has posted two images. The one on the left is an image or a picture from a protest, and the other one is coming from a video with a text overlay. So using the techniques we've seen, we can analyze these images in several ways. You can start by generating a global description of each image, and then you can segment the image to identify different elements we have in there. And we can even translate and perform sentiment analysis on the text we find in the image. Furthermore, as we see here for the image on the right, our system has raised a red flag or has issued a warning. This is because similar images to this might have been detected in our datasets. And this kind of alert can help an analyst identify potential threats or manipulation and respond adequately. This specific example was used in the Israel-Palestine conflict, and this image is not real, but it's coming from a game called Arma 3. And similar tactics had already been used over the last 2 years in the Russia-Ukrainian conflict as well. For the image on the left, we can do exactly the same thing. We have our description, and our segment identifies a text that can be translated into English or Dutch or French or whatever you need, and we also have a sentiment. And then combining those two generated analysis, we can create an automated profile of the account regarding a specific topic. And this profile can provide insights into the user's interests, their beliefs, their activities, and help us understand their role within the global social network. And so here we can have the machine generate the stance of this specific user, giving the limited information we have here on the Israel-Palestine conflict. And through this example, you already see how a combination of computer vision and natural language processing can help in a comprehensive analysis of social media content. Now, let's extend the previous example and also bring network science into the mix. We'll consider multiple users in a social network where each user is represented by the shaped person icons we see on the slide. Initially, the network is simply constructed by connecting the users if they publish similar content. This already gives us a basic understanding of a relationship between users based on shared interests or topics. Next, we can refine our network by also considering users' activity patterns. Some connections may disappear because, although the content is similar, the user's activity patterns are different. This can help us identify more meaningful clusters or relationships within the network. And then finally, we can use a weighted combination of content similarity and activity patterns to define the connections. In this network, you'll see that some edges are thicker than others, indicating stronger connections based on our combined criteria of content similarity and activity patterns. The anonymous person-shaped icons are now replaced by illustrations of bad guys or innocent sheep, representing potential perpetrators or victims of an organized campaign. And through this example, I hope you can see how network science can add an additional layer of depth into our analysis, helping us to identify patterns and relationships that might not have been apparent from the content analysis on its own. Now, for social media intelligence to be effective, I believe we do need a close collaboration between technicians and analysts. The analysts brings a specific way of working and understanding the context, while a technician brings a technical expertise to propose innovative methods and solutions. And ideally, an analyst would also have some technical background to facilitate this collaboration, or vice versa. You can also have a technician that has some notions of the work that an analyst is doing. Second, well, you can't perform analytics without data. Having access to relevant, high-quality data that is readily available is key to any SOCMENT initiative. I think, as we have seen over the last couple of years, AI techniques are evolving at a very rapid pace. And in order to stay up to date with the latest techniques and ideas, you would almost need a dedicated team for a dedicated TechWatch team to stay up to date and also to try to tinker with new methods and see how that can help the current workflows you already have in place. Small downside maybe, some of the things I've shown are very promising and very interesting, but typically the more advanced the methodology or techniques you want to use, the more compute power is required. And this can definitely be a limiting factor, especially if you're doing large-scale or complex analysis. And finally, we have a potential threat for the current know-how that has been built up, and that's knowledge retention. And the number of people working in this domain at a technical level is relatively limited. And so even when you are considering commercial solutions, you still need a technical background to appreciate or evaluate the quality and the potential of some of the proposed solutions from industrial partners. This makes knowledge retention and skill development critical, in my opinion, for the long-term success of SOCMENT initiatives. So thank you for your attention during this presentation. We've covered a lot of ground today, from the very basics of what is SOCMENT to the challenges of data analysis, the potential of techniques like computer vision, natural language processing, and network science, and bringing those three together. I've also mentioned the importance of collaboration, data access, staying up to date with the most recent techniques, the limitations of compute power, and the importance of knowledge retention. I do hope that this has given you a deeper understanding of the complexities, but also of the possibilities in the field of social media intelligence. Now, I'm sure you have questions, thoughts, or ideas you'd like to discuss, so let's move on to the Q&A session. Please feel free to ask anything related to the topics we've covered today. Thank you.